first subtracting integers. Okay, we're also going to talk about adding them, multiplying them, and dividing them. Okay, so you got to listen carefully. I will try to be as specific as I possibly can so you don't mess this up. All right, the first thing let's talk about, if you have two positive numbers, okay, if you have two positive numbers, whether you're adding, subtracting, multiplying, and dividing them, what is your answer going to be? Is it going to be positive or negative? It's going to be positive, right? Of course it is. Okay. Now, in the event that you are adding and adding one, let me backtrack. You have a positive integer and a negative integer. Your final answer, is it going to be positive or negative? Okay, now we're specifically talking about subtraction, multiplication, and division, not adding. Adding is something different. We'll talk about that a little bit later. I heard addition, yes? Everybody agree? Yes? It is a negative number. This is why you might want to pay attention to that. If the tables are turned and you have a negative number and a positive number, what does that yield? Well, since it's the same one above it and it's backwards, it's still a negative number. Oh, this is where you better pay attention. And then if you have a negative number and a negative number, what's that going to yield? That is going to yield a positive. Oh, just watch. Got to write this stuff down because it's nowhere to be found. I believe the kids earlier today, you got 176 problems to solve tonight. Better pay attention. Better write some notes down. All right. Everybody okay with that? Now, if you recall, we actually did this late August, early September. This was kind of part of chapter 1. I know that was a long time ago. I get that, but we did cover this briefly. All right. Everybody good with that? Okay, now let's put it in practice. Let's see what this means. Okay, so let's start off really easy. So if we have something that looks like this, okay, our answer is what? All right, everybody knows that it's 18. Now, right, that's pretty simple. You've been doing that since 2nd, 3rd, 4th grade, whatever. Okay, so this is a subtraction problem, yes? Okay, to make your life easier when it comes to subtraction, we want to turn a subtraction problem into an addition one. And I found out that you don't do this anymore at the elementary school, right? Is that fair to say? Okay. This does make your life easier. I don't know why they stopped showing you. I don't know. I don't know. Okay, because 20 minus 2, I know you all look at it as 20 minus 2, but in the math world, we really look at this like this. This is really what it looks like. Might want to write that down. Okay, so this in the world of math, you should know by now that everything has a property to it, yes? A property, a rule, or a theorem, or something. Okay, you don't need to really know what this is called, but the technical term is the algebraic definition of subtraction. That's the technical term. That's a fancy way of saying we're turning a subtraction problem into an addition one. That's all we're doing. Now, notice what I said. We're turning a subtraction problem into an addition one. Right? Okay. Are we turning an addition problem into a subtraction problem? No, do not make that mistake. We're not doing that. Okay, we'll talk about addition here in a minute. Okay, now what just happened? What just happened was we're taking the subtraction sign and turning it into an addition sign. Might want to write this down because I am explaining the definition and showing you. Turning a subtraction problem into an addition one, you take the subtraction sign and change it to a plus sign. I'm not sure why your Chromebook's open. No idea why. You better take notes. Now, what happened to the number behind it? Be kind of specific here. Andon? 2. I need more than just a negative. It changed to its what? No, not absolute value. It changed to its opposite. Very good, sir. So the number behind it, whatever number that is, changes to its opposite. Hence, now we have 20 plus a negative 2. So that's like saying you have $20. You bought something for $2. How much do you have left? You have $18 left. You had to spend $2. That's a negative. Okay, everybody okay with that? Right? And again, this might be fairly new to you, but we have covered it, and you're going to get plenty of practice. All right, so let's look at something a little bit more interesting, like something that looks like that. Again, I'm encouraging you to write these down. All right, here's the first question. How can you tell the difference between a minus sign and a negative? Maggie, what do you think? Okay, that is actually partially correct. You are right. I can't take attendance when the program doesn't let me to open up. Right. Listen, I shut down the whole computer. I did everything. I shut it all the way down. It came back up, and I'm trying to take it, and it keeps spinning. Okay. All right. Yep. Right. Okay. So yes, Maggie, you are partially correct. So let's talk about this out here. This is definitely a negative. That is correct. Okay. How do we know that the one in blue there that I'm circling, is that a minus or a negative sign? And how do you know, Andon? Okay, I'm glad you said that. Everybody's been saying that all day. So let me rewrite it. So now what? No, I'm just testing your knowledge. I'm just, this is my job. Now there's no parentheses. Now, does something look funny up there? Okay, see, I told you by the end of the year you would get to this point. What looks funny? Oh, okay, there's two, well, we'll just say there's two signs side by side, yes? Okay, as I told you way back in the fall, that is really bad math. You can't have two signs side by side in the world of mathematics and mean something. That looks really, really funny. Okay, and it sounds like it's starting to do that with you. That's good. Okay, so we got to put parentheses around something. So the question once again is the blue that I'm circling, is that a subtraction or minus sign, or is that a negative sign, and how do you know? Jaden, what do you think? The answer is this is not a tough answer. In all honesty, it's a very first, second grade answer. It's very, very easy. It's just you're not used to it yet. I get that. Maggie. Well, this is correct. It doesn't come before. So is it a minus or a negative? Okay, how do we know? Just because it comes after? Okay, but what about that sign then? That comes after. What do you think, Renato? Well, we don't have an equation. We don't have an equal sign anywhere up there. Gabe? The simple answer here, Joe, you're missing the really obvious. It's a subtraction or minus symbol because it's between two numbers. That's it, man. That's it. This isn't tough. Okay, it's a subtraction sign because it falls between two numbers. You can't say negative 66, negative 10. Right? The math person is going to go, what do I do operationally? Like, it doesn't make any sense. Okay, so if it falls between two numbers, it's a minus sign or a subtraction sign. Obviously, in this case, if it's separated by a parentheses, then that's the negative, right? This is the negative in yellow. That's the subtraction sign, the one that falls between two numbers. So far, so good. All right, let me rewrite this so we can clean this up and we can solve it. All right, so we've got that situated. Now, we have a subtraction problem, yes? Okay, so the rule says to change the subtraction sign to addition. And what do we do to the number behind it? Well, we change it to its opposite. What's the opposite of negative 10? That would be a positive 10. So now the question is negative 66 plus 10 gives us a negative 56, not a positive one. Okay, now listen up, because this is where some of you go a little funny as well. Okay, we had a subtraction problem, yes? We did. And we turned it into an addition problem. So far, so good, right? This is like second, third grade math. Okay, now listen though. For addition, the rule says whatever number is larger gets the sign. You hearing me? Look here. When it comes to addition, whatever number is larger gets the sign. Is 56 bigger than, or I'm sorry, is 66 bigger than 10? Yes. What is associated with 66? That's why the answer gets the sign. Light bulb just went off. Clean up on aisle 3, please. Okay, does that make sense? Yes or no? Okay, this is you might start off to have a subtraction problem, but then it turns to addition, and now the rules change. See, you have to be aware of what you're dealing with. Does that make sense? As Gabe's looking out the window. All right, next one. What if we have something that looks like this? I know most of you are thinking right now that this is the answer. Well, that's an answer that a lot of people will give. Okay, or even this. Okay, but if we have this, oops, we change it to an addition problem, yes? Okay, when you change it to an addition problem and the answer behind it is positive, please do not make this mistake. Again, what's wrong with that? Aggie? Well, it was, but now we turn it into a plus sign. We don't need what? No, that's not a subtraction sign. That's a negative. That's a negative. That's not a subtraction sign. Please put parentheses around it. The problem is you don't ever have two operational symbols side by side without separating them somehow. And in this case, we're going to make it really easy. We're going to use parentheses. So now our answer here is not -4. That would be a -6. You're adding two negatives. Yes or no? Yes? Because adding two negatives sometimes you want to make it a positive or you want to do something else. Think of it as shopping. Okay, look at our example. We have -5 plus -1 is equal to -6. So let's put this in shopping terms and going to Starbucks. Well, you'll understand it. If you go to Starbucks and buy a drink for $5, how much do you owe the cashier? You owe them $5. That's a negative number. You owe them $5. That's $5 out of your pocket. That's not a positive number. Now, all of a sudden, you buy that and you look in the case and you're like, wow, I really want that cookie. That costs $1. So, how much do you have to give the cashier total? You have to give them -$6 out of your pocket. You are losing $6 by buying those two products. Does that make sense? Okay, because sometimes when adding negatives, it gets funny in your brain up there. You're like, oh, I got to add something. No, you don't. If you keep buying something, that's negative money out of your pocket. Right? That's not a positive. Okay, you good with the positive and negatives? When we add and subtract them. Okay, you're going to get plenty of practice. And I said that they only applied for subtraction, multiplication, or division. What do we have right here? Doesn't work that way. Not for addition. The larger number gets the sign. When you add two negatives, you're going to get a negative. You're buying things up, and that's money out of your pocket. Okay? And then remember, when we talked about this, look, the larger number gets the sign when you add. Okay? You don't have a negative and a negative or a positive and a positive. If you have one of each, the larger number gets the sign. Okay? All right. It's actually a little bit easier, to be honest with you, when we talk about multiplication and division. Right? We have -7 times 7. Okay, so the easy part is do the math. What's 7 times 7? 49. Now you have to know these rules that we started with. Okay? I hate to call it a trick, but do you see the little trick up on the screen of whether your answer is positive or negative? Take a look at the signs. Anybody see anything that can help you memorize these, Annan? No, not all opposite. Okay, what about two negatives? Okay, so listen carefully. Look up there. Look at the top and the bottom. If the sign is the same, your answer is going to be positive. If you have two opposite signs, your answer is going to be negative. When it comes to subtraction, multiplication, or division, not addition. Everybody good with that? That's why you can use that while you do these, because you might need that chart. Okay, going back to this. So our answer is going to be positive or negative? It's going to be negative. Why? Because I have a negative number here. I have a positive number here. So that's yielding us a negative number. Because I have one negative and one positive. It doesn't matter where they're at. It's going to give me a negative number. So far, so good? Okay, and that also applies for division. No different. Okay, listen, I don't want to know the number. I don't want to know the answer. Or is your answer going to be positive or negative here? It's going to be positive. Why? Because you have a negative number, and a negative number is going to yield you a positive answer. And then all you have to do, what's 8 divided by 4? Problem solved. Okay, you good with subtraction, multiplication, and in all seriousness, multiplication and division, when we're talking about positive and negative numbers, are easier than adding and subtracting, to be honest with you. All you got to do is look at the signs and multiply and divide, and you got your answer. Okay. The more interesting parts are when you are changing a subtraction problem into an addition one, and now you got to remember, oops, now the answer is the larger sign. Is that a larger negative or is it a larger positive? Okay. Right. And the last one. Okay, we touched about this. Remember those? What was that name? What was the name of those? The absolute value. That is correct. And the definition of absolute value is the distance. Okay, well, the distance away from zero. Okay, remember, we can represent in a problem, we can represent distance to be a negative number. We can represent it be a negative number, but on a number line, distance cannot be negative. Right? You didn't remember we talked about that? You don't drive negative 1,000 miles somewhere. Right? And our other example that we had, you're swimming on top of water, right? Like the ocean, right? And then somebody dives down. Okay, you can represent that as a negative number. They dove down negative 80 meters. But in reality, that is a positive distance from the top of the water down to where they dove. Does that make sense? Okay, because remember, distance cannot be negative. We can represent it as a negative number, but in reality, it's really a positive distance. Okay, so back to our problem on the board. Anything inside the absolute value symbols has to be what? Positive or negative? Has to be positive. So a negative 6 is actually a 6. So if we did it on a number line, that goes from there to there. That's a positive distance. Okay, it cannot be negative. Now, the flip side of that is if we have something on the outside of the absolute value symbol. If it's on the outside, that's fine, right? We have a negative on the outside. Inside, once again, has to be positive, right? Anything on the inside of the absolute value signs has to come out to be a positive number. Okay, This negative sign on the outside just carries over to your answer, which would be -5. So this is one of those examples where, yes, the distance is 5, but yet maybe we're 5 feet underground, right? Or we're 5 feet, whatever, underwater. Okay, and that's where this negative comes in. Is that making sense? Okay, and that should be a little bit review too, right? Okay, last one, right? So what if we have this? What do you think your answer is going to be? It's going to be -2, right? Anything on the inside has to be positive. If it's on the outside, you carry it over to your answer, and that's going to be -2. Very good. That's correct. All right. Any questions at all over adding, subtracting, multiply, dividing integers? All right. Absolute value is pretty good. Okay. So you have a lot to do. So you've got a subtracting integers paper that will be due tomorrow. You have a number set and an absolute value paper, which is due tomorrow. You have an IXL, which you need to get 100% on. And then you have your homework. So you have plenty to do in this last 20 minutes and all of 11th period. Okay, you have the rest of the time to do it.